It's like...
Okay. So in this video, we're basically going to show another scenario where we're going to interrupt the flow of electricity back to the spark. We have, again, some spare parts here that are just a little bit of copper that we're throwing right in between the rods. So here we go.
Yeah. So we will try to start the fire. Push again on the on-off button and then on the OK button. Then it gets warm.
Yep.
Yeah, it gives beep, so I know we are now in the second phase. In the second phase, normally the spark is coming in. So yeah, we see a spark. We see a flame. So we are now in the third phase. And normally we should give a second beep to say okay. The ionization current comes on the ionization rod, will go through the flames and come back over the yellow cable. But now the circuit is interrupted.
Which is not why the reason why we did not get the second beep.
Yeah, exactly.
It's not confirmed.
Because there is something interfering.
Correct.
We pretend if we don't know what is the cause of the problem, so we will take our 5-minute method. We know that it got through the first phase, we saw the spark, we saw gas coming in because we saw a flame, but before the second beep, normally you have a second beep here, the fire went out. So we have to look for the cause of the problem in phase 4, and that's on page 6. Also, the remote control is showing 08A. So here it's stated that remote control, the ignition transformator couldn't be defect because it worked all well during 10 seconds. There is something wrong with this ionization circuit. So here it's written, check the wiring, particularly the ionization wiring. So here is the black one. The wire is okay. And then we will measure ionization.
These wires, they lead back to, just so we know where we're going, one to this particular unit.
This is the ignition transformator that's connected to the ignition rod, and the other one is the ionization cable.
Correct.
That is connected to the ionization rod. So what we are going to do now, we are going to put our multimeter into the circuit to measure if there is ionization.
Just so, because I missed it, you pulled that out of where?
Yeah, it's the first contact next to the cable, where is normally the ignition spark.
Yep, so there's two
next to the blue cable.
Yep, so there's two there, and it's actually the first one.
Okay. So what do? You see also on the picture, you see the ionization, the red one, you put into the black ionization cable. So I can put it in here. Oh, it loosens, so I have to put it back again. Yeah. And the other part of my multimeter, I hold against the contact.
The very first one, closest to the white contact.
And I put my multimeter on microampere. So not milliampere, but microampere. As you have to have a multimeter that can measure 0.1 microampere. Then of course I have to light the fire again because I can measure the current when I don't have the circuit.
So clear the remote control 6 times, is that correct?
6 times, you can push 6 times, exactly.
1, 2, 3, 4, 5, 6.
Yeah.
And there it is, back to a normal screen.
Yeah, so we are going to light the fire again, push on the on-off button, you OK, it will light.
The word warm is flashing. And we're going to measure that now.
Yeah, the spark is coming in, the flames are coming in.
We know that that's going to go out shortly.
And we see 0 microampere, so we have nothing. So this is also the reason that the central brain doesn't get any current and then it shuts off, of course. So you see here on the 5-minute method, it should be more than 0.5 during lighting, and after lighting, so after the second beep, it should be 0.7. So we now measure nothing, no current is measuring, and then checking if a decorative furnishing on the heart is touching the ionization rod. We're checking now, and that's really the cause of the problem. So we remove it, and then this should do the job. If there is nothing interfering, then the ionization rod is faulty. So you should unscrew this and then put a new one. So, but check well that it's not only at the end of the rod that is no decoration, but also here at the beginning, because normally it's covered by a decoration grid, and you also have to look.
What else
inside.
could actually be causing a blockage other than, you know?
You have like brown lava stones, and this kind of brown lava stone could also, when you don't pay attention, when you put the media on, this kind of a stone could drop into the hole where is the ionization rod. So in this way, it could block
Corrosion?
it. The second thing would also could be that we put normally CalGlow on the fillings of the...
The CalGlow, which is, some people have seen mineral wool. This is more like steel wool. It acts in the very same way. That's part of the decoration of the burner. It's called CalGlow.
Yes. And this simulates the glowing effect of the locks, and normally you have to push it and put it underneath the locks so that it's not going to change of position when you are lighting the fire, because through the draft is quite a light material, it could be pulled against the ionization rod. And this CalGlow is so fine that you often can't see it with the eye. So if you are checking for decorative material, so on the rod, check it with the lamp of your telephone, because then you will see well if there is anything. Also, this small CalGlow is touching your ionization rod.